We're going to learn section 4.4, determinants and Kramer's rule. We're also going to find determinants of 2x2 and 3x3 matrices, and we're using Kramer's rule to solve systems of linear equations. You have 3 vocabulary words that will be defined as we go through the lesson. First, every square matrix, a 2x2, a 3x3, and n by n, because rows and columns are equal, has an associated value called its determinant. That should probably be apostrophe, shown by straight vertical brackets. The determinant is a useful measure, and we'll see why later this lesson. So if you have matrix A, which is brackets, when we change those brackets to straight bars, straight vertical brackets, it's a determinant. So the determinant of a 2x2 matrix is the difference of the products of the diagonals. So if you see here, we're going to take the determinant of this matrix, which means we're going to take the diagonals products, which is multiply 1 times 4, and subtract 3 times 2. It has to be that order because subtraction is not commutative. So we take the products, or the difference of the products of the diagonals. The determinant of matrix A may be denoted as determinant A or bar A. Don't confuse the bar A notation with absolute value notation. So we're going to take this right here and try a few. Example 1, defining the determinant of a 2x2 matrix. So we're finding the determinant. We take the difference of the product of the diagonals. We always go up to down, left to right. So 1 times A minus 5 times 4. So that gives us 8 minus 20. The determinant is negative 12. Pretty simple, right? Let's try another one. Find the determinant. Again, top to bottom, left to right. So, product of the diagonals, difference, 1/2 times 2 is 1. Negative 1 times negative 1/2 is positive 1/2. So 1 minus 1/2 equals 1/2. The determinant is 1/2. Okay, you try one, find the determinant, push pause, try it on your own. There you go. Pretty simple, right? Try this next one, push pause. Alright, I gave you every possible answer here. First, the multiplication, which gives me 1/4 minus 15 over 6. I changed it to common denominators, did the subtraction, improper fraction, mixed numeral. Alright, you can use the determinant of a matrix to help you solve a system of equations. For 2 equations with 2 variables written in ax plus by equals c, this is called standard form, you can construct a matrix of the coefficients of the variables. We're going to use this definition again. This is a coefficient matrix, so it's just the numbers in front of the variables that go in your brackets. The coefficient matrix for a system of linear equations in standard form, there's that standard form again, is the matrix formed by the coefficients of the variables in the equations. The determinant of the coefficient matrix, so I've got the straight bars, is A1, B2 minus B1, A2. Okay, that's your determinant. So Kramer's rule for 2 equations gives us, hold on. We'll go over an example, it'll make much better sense. But if you see right here, I have A1, B1, A2, B2, and that's right up here where we're going to find our determinant of the coefficient matrix. Now, when we're solving for x, we replace A1 and A2 with C1 and C2 right there. And when we're solving for y, we replace B1 and B2 with C1 and C2 right there. And D is your determinant of your coefficient matrix. So let's go through an example. Your numerator, at least one of these is 0. You can use Kramer's rule to tell whether the system represented by the matrix has one solution, no solution, or infinitely many solutions. This is Kramer's rule. So if your determinant is not equal to 0, your system is consistent and has one unique solution. If your determinant is equal to 0 and at least one numerator determinant is 0, so if you go back here, so if D equals 0 and at least one numerator determinant is 0, the system is dependent and has infinitely many solutions. If D equals 0 and neither the two numerator determinants is 0, the system is inconsistent and has no solutions. Finally, an example. Use Kramer's rule to solve each system of equations. First, we're going to find D, the determinant of the coefficient matrix, with a pen. So I'm taking the coefficients 2, 1, 3, and negative 2, and finding the determinant. 2 times negative 2 minus 1 times 3. Determinant equals negative 7. Okay, D is not equal to 0, so the system is consistent. Now let's solve for x. First, I'm going to replace this column right here with my constants. So 10 and 8, 1 and negative 2, over what we just found was D. Okay? 10 times negative 2 minus 1 times 8 over negative 7. Negative 20 minus 8 gives me negative 28 over negative 7, x equals 4. Okay, let's hold on to that. Let's find y. So now I'm taking the same matrix, and instead of this column, I'm putting in my constants. So I replace 2 and 3, and instead of 1 and negative 2, I put in my constants over D. 2 times 8 minus 3 times 10, or 10 times 3. So I get 16 minus 30, which is negative 14 over negative 7, or y is positive 2. So we have our answers, x, y, right down there. Let's try another one. Use Kramer's rule to solve each system of equations. So first I'm going to find my determinant of my coefficient matrix. Actually, I have to write this in standard form first. So 3x minus 2y equals negative 5. And I'm going to move that over, so positive 9x minus 6y equals negative 15. And my determinant of the coefficient matrix. Coefficient matrix is 3, negative 2, 9, negative 6. Determinant equals 3 times negative 6 minus negative 2 times 9. Negative 18 plus, negative 18 plus 18 equals 0. D equals 0, so the system is either the system is either inconsistent or dependent. So we need to figure out if the numerators for x and y, see what they are to see if they're 0. We go back and check that chart. So if we solve for x, I take this first column and replace it with my constants. -5, -15, -2, -6. And we don't even have to write over 0, because we know we can't divide by 0. So -5 times -6 minus -2 times -15. That gives me +30 minus +30 is 0. Since at least one numerator is 0, the system is dependent, has infinitely many solutions. If we checked y, we would see that we're going to place this column with our constants. So 3, 9, -5, -15, and again over 0. 3 times -15 minus -5 times 9. This gives me -45 minus -45 plus 0. Okay, a system is dependent and has infinitely many solutions. Actually, this is a you try. Okay, use the same format and try to solve this one. It's already in, well, you have to put it in standard form and solve the system. So again, our determinant was 0, so I went ahead and tried to solve our x and y. Because d equals 0 and one of the numerator determinants is equal to 0, the system is dependent and has infinitely many solutions. Alright, I'm going to challenge you guys a little bit. To apply Kramer's rule to a 3x3 system, you need to find the determinant of a 3x3 matrix. One method is shown below. Okay, take your time and look at this. Rewrite the first two columns at the right side of the determinant. So here is my coefficient matrix. I take these first two columns and I copy them again. Add the sum of the products in the red diagonals, and then subtract the sum of the blue diagonals. So we go down here, add these, okay, A1, B2, C3, so multiply, 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 plus multiplication, plus multiplication. Then subtract these multiplied, plus these multiplied, plus these multiplied, and that's our determinant. Example 3, we're just going to find the determinant of a 3x3 matrix. So I've got the first column, the second column, try to keep everything as neat as possible, third column, and then I'm going to take that first column, write it again, and that second column and write it again. Okay, I'm going to use some red, and I'm going to cross here, there, and there. So 2 times 2 times 8, plus 4 times 3 times 1, plus 1 times 5 times 4. And then we're going to subtract. I shouldn't have used blue for the numbers, so I'll use black. This diagonal, that diagonal, that diagonal. So I'm subtracting 1 times 2 times 1 plus 4 times 3 times 2 plus 8 times 5 times 4. Close parentheses. Okay, I'm going to push pause and use my calculator. Well, yeah. So you see I have 32 plus 12 plus 20 equals, I'm subtracting the quantity 2 plus 24 plus 160. And that gives me a final answer of -122. Okay, you guys try this one. Find the determinant of a 3x3 matrix. There you go. Your determinant is 75. Kramer's rule can be expanded to cover 3x3 systems. And if you see, first we find our determinant, then we solve for x, y, and z. So we solve for x, we replace our first column by our constants. We solve for, and then find the determinant of that and do your division. Next, we replace our second column, then our third. Again, if d isn't equals 0, the system has a solution. If d equals 0 and no numerator 0, then the system is inconsistent. If d equals 0 and at least one numerator is 0, the system is dependent. I gave you a bonus. Go ahead and try it. I'm going to give you a clue. You can enter the matrices into your calculator, and there is a DET function under math that it finds your determinant for any matrix you plug in there. But it's a good bonus. It's just a lot of number crunching, but not necessarily difficult math. Just hard to keep everything organized. Good luck.